Hello guys, welcome back to YouTube channel. Today we'll be discussing the first three problems from the Div 2 contest of the Codechef Starters 208. I'm Sahib. Let's begin. Let's start with the first problem, alternate jumps. Let's quickly read the problem statement as well. Problem statement goes something like this. There are n lily pads arranged in a line. They are numbered 1 to n from left to right. A frog is initially standing on a lily pad n. The frog loves to jump, so it will perform a sequence of n minus 1 jumps with alternating directions as follows. And this information is given here, how the frog will jump from its current position to the position it wants to jump at. And here we have given two more pieces of information, which is if I is odd, the frog will jump to the lily pad n minus 1 positions to the left of its current position. That is, if its current position is x, its new position will be x minus n minus I. If I is even, the frog will jump to the lily pad n minus I positions to the right of its current position. That is, if its current position is x, its new position will be x plus n minus I. It can be proved that all of frog jumps are valid. That is, there will always be one lily pad. There will always be one of the lily pads 1 to n. If you are given n, can you find the number of the final lily pad the frog will jump at? So the problem statement might seem like a little tricky when you read it for the first time. So what we'll do is we'll try to understand this problem statement by taking help of this given sample input, right? So let's take the fifth one, n is equals to 5. So in the input, we are just given number of lily pads we currently have. So let's take n equals to 5 and let us suppose say these are the 5 lily pads, right? These are the 5 lily pads, and it's given in the question that frog is currently at initial position is nth lily pad, right? So frog is initially standing on nth lily pad, and what he is doing, he is performing total n minus 1 jumps. So initially we are just given the number of lily pads. We have a frog who is at initial position n equals to 5. If we have indexing from 1, 2, 3, 4, 5, and he is performing in total n minus 1 jumps, right? And now next part, how is he performing all these jumps? So that information is as well provided. Let us suppose say for ith jump, if I is odd, then frog will move to its new position, which is x minus n minus I. If I is even, the frog will move to its new position, which is x plus n minus I. So here first we are keeping track of which jump is this, right? So for jump I equals to 1. For first jump I equals to 1, I is odd, right? So in this case, what's mentioned in the problem statement is if I is odd, frog will jump towards the left, and its new position will be x minus n minus I. So its current position is 5, and its new position will be 5 minus n, which is again 5 minus I. I here is again 1. So this is what will be its new position after the first jump. So 5 minus 1, 4, 5 minus 4 is 1. So frog will jump to this position after the first jump. After the first jump, frog will jump to this position. Now, how many jumps are we doing total? N minus 1 jumps, right? So we have to simulate this entire thing more 3 times. So for I equals to, now what is happening? For I equals to 2, now the number of the jump is even, and in that case it's mentioned that its new position will be x plus n minus I. So its current position, which is 1 plus n minus I. Again, n is 5 and I value in this case is 2. So now its position will be 5 minus 2, 3 plus 1, 4. So for the second jump, frog will now move back to fourth position. This is where frog is present in the second jump. Now let's simulate this even more for I equals to 3 and for I equals to 4. Yep. Let's say for I equals to 3, what will happen? Again, the jump number is odd, so its current position is 4. We will do 4 minus 3. My bad, this will not be 4, this is n, so this will be 5 minus 3, right? And its new position here will come out to be 5 minus 3, 2, 4 minus 2 is 2. So it will now jump to second position, which is this one, right? And for the last jump he is making, I is again now 4. So for the even number of jump, this is the formula. Its current position 2 plus n minus I. N is again 5 and I, this is fourth jump, will subtract 4. So its new position will be now 5 minus 4, 1. 2 plus 1 is 3. And this will be its final position as well. This is what will its be final position. And if you look at the output here, this is what we are printing. For n equals to 5, the expected output is 3. I hope the problem statement is a bit clear now. We are simply given n equals to 5, number of lily pads, and the initial position of the frog is n itself, and we are performing total n minus 1 jumps. Now, for each jump, if the jump number is odd, this is how we are moving. We are simply doing x, which is its current position, minus n minus 1. X minus n minus 1. And if the current jump number is even, we are going with this formula. And when we simulate this entire thing, the final number of the lily pad, which is coming out to be 3, and that is what we have to print in the output. So if you look at the constraints here, it's pretty small. T is going up until 100 and n is going up until 100 as well. So we can brute force our way to this. That is, we can simulate this entire thing. We can have a while loop which will run for n minus 1 times, and inside that while loop, what we'll do is we'll update our position according to the jump number, right? If the jump number is odd, we will do this. If the jump number is even, we'll do this, and we'll do this total for n minus 1 times, and whatever the answer is remaining at the last, we'll print that as our output. So that is what will be my approach for this problem. So let's look at the code part for the next one. Let's quickly read the input format. We just given t number of test cases and then n denoting the number of lily pads. So we have taken that input, and next for the next part of the code, what I'll simply do is simulate the entire process which is being described in the question. So I'll have my variable, position variable. So initial position of the frog is n, and then total jumps that am I supposed to make, which is n minus 1. And I'll as well have an variable to keep track of the current jump index, right, which is 1. And next part, what I'll do, simply write a while loop and my termination condition will be simply while my current jump is less than total number of jumps that I'm supposed to make. And inside of this while loop, what should I do? I'll simply check first if current jump index is odd, right? If it is odd, in that case, how are we updating the value? In this way, we are subtracting from the current position, which is POS, n minus I value. So I here is the current jump index, right? Else what am I doing? If the jump number is even, then I'm adding n minus current jump value, and Next, simply increment my current jump variable. That's the entire value for this, and at the last I'll just print whatever the value that is present in my position variable. Let's try to run this and see. Yep, it's passing the sample cases. Let's quickly submit this as well. Cool. Let's move on to our next problem. Sabotage is the name of our next problem. Let's quickly read the problem statement. Chef is participating in a programming competition. Currently, he has a score of X. There are n participants other than Chef. The ith of these participants has a score of AI. Chef's rank in the contest is determined as follows. Count the number of indices such that AF is greater than X. Let this count be R, then the chef's rank will be equals to R plus 1. Now, Chef would like to improve his rank, so he decides to sabotage his opponents. Sabotage operation is defined as follows. Choose any index from the array, set AFI to 0, and then add 100 to X value. That is, increase Chef's score by 100. Since there's not much time remaining, Chef can perform the sabotage operation at most k times. Find the minimum rank Chef can achieve at the end. So, interesting problem statement. Again, let's understand this by taking the help of this sample input. So, in the input initially, we are provided with three things. First is n, number of participants in the competition, right? And next value we are given X, which is the chef's current score. So there is a competition going on in which there are n participants. Now, apart from this n participants, chef is also participating in this contest initially with his score as X. Now, what is happening here is we want to find the rank of the chef, right? We want to find the rank of the chef, and rank is simply determined by how many participants. Let's suppose say there are R number of participants who has a score higher than the chef's score, right? So if chef's score is X, let there be R participants whose score is higher than X. Then chef's rank will simply be R plus 1. Now, what we want to do here is we can perform a sabotage. We can perform a sabotage operation. Now, what is this sabotage operation? We can choose any participant and set his score to 0 and add 100 points to our score. But the thing here is we can perform this sabotage operation at most k times. So for the output, what I would want to find is the minimum possible rank the chef can achieve after performing this sabotage operation k times. Right? So what could be the minimum possible rank chef could achieve? Let's take the second example here, or let's take the third example. It's a little bigger one. So for we have 5 participants. Chef's initial score is 415, and chef can perform the sabotage operation 3 times, right? And the scores of the participants is as well given to us: 5315, 123, 2523, 6320, and 789. These are the scores of the participants of the contest. Now, what can we do here? I can perform sabotage operation 3 times, right? So, ideally, to which participants would I want to perform this sabotage operation? See, if a person's score is already less than chef's score, it doesn't make sense to sabotage him because his rank is already higher than our rank. We would want to perform the sabotage operations on participants whose rank is lower than us, meaning whose score is higher than us, right? So, how many participants do we have here whose score is higher than our chef's score? So this participant, we have 1, we have 2, we have 3, and we have 4. So we have these 4 participants whose score is higher than the chef's current score. We can sabotage any 3 of them. After sabotaging any 3 of them, what will be the chef's new score? It will be plus 300, right? Because for every sabotage operation we are getting 100 score. And let us suppose say we are sabotaging these 3 participants. So this is what the new score of the participants looks like. Now if we calculate the rank again, what is the chef's new rank? Chef's score is 715, and there is only one participant higher who has higher score than 715, right? So chef's new rank will simply be 2. Chef's new rank will simply be 2. This is the minimum possible rank chef could achieve after performing sabotage operation 3 times. It doesn't matter which participant we sabotage amongst these 3 selected. Even if we have sabotaged, let's suppose say, not 6320789, even if we change his score to 0, we have still this participant whose score is 6320, which is obviously higher than 715. So amongst these 3 participants, doesn't matter which participant we can sabotage. So finally his rank will be 2. This is the minimum possible rank he could achieve. I hope the problem statement is a bit clear now. Now let's, for the next part, let's see how we could solve this problem. So how could we solve this problem? Let's take this same example again. So my initial score is 415, right? My initial score is 15 and I can perform this sabotage operation. Now, so the first thing here is what I will do is I will now check if I perform, let's suppose this sabotage operation 3 times, what will be my new score? I will first check that part. So I can perform this average operation 3 times. So I'll get 300 points. So my new score will be 715. So now I just simply need to check what rank I can achieve with this new score, right? How many participants do I have in this array which has a score greater than this? So again we have 3 participants here, 1, 2, 3, sorry, we have 4 participants, not 3, right? So with this average operation I can get 300 points and my new score will be 315, and currently we have 4 participants whose score is greater than 715. Now along with adding 100 to my score, what else can I do with this sabotage operation? I can make them 0 as well, right? So I will make each of the participants score 0. But first, how will I find that there are 4 participants whose score is greater than my 715 score? How can I do that? So we can first, of course, just use a simple for loop which will iterate over the array normally and keep a counter. Or we can, if you want to optimize that part, we can perform binary search here as well, right? So we can sort this array 1 2 3 7 8 9 2 5 2 3 5 3 1 5 and 6 3 2 0. So after sorting this array, you can just simply perform binary search and find the index of the last element which is greater than the 7 1 score. In that case 0 1 2 3 4. In that case I will return 1 as the answer. So my total number of participants whose score is greater than 715 will simply be n minus this one, which will be 5 minus 1 equals to 4. So using binary search, this is how I can find out the number of participants whose score is greater than my current score, right? Now after finding these 4 participants, what should be my next step? See, we have just done one part of the sabotage, which is increase score, but we can as well decrease my opponent's score, right? So from this 4, I can choose any 3 participants and make their score to 0, right? So I will choose any three participants and make their score to 0. After doing that, what will happen? There will only be one participant left whose score will be greater than us, right? So there will be only one participant left whose score will be greater than us. So my rank will be 1 plus 1, which is 2. So this will be my entire process. First, simply find out the number of participants whose score is greater than our score, including the sabotage operation, and you can do binary search for that. And next part, what will I do? I will, mm, however many participants I have, I will subtract k here. That is meaning make all the scores to 0. So after that, whatever answer that is remaining, that will be the number of participants whose score is still higher than my current score. And to get a rank, I'll just simply perform plus 1 here. So this will be my entire logic for the code. So let's code up the exact logic as well. For the input format, we're given t number of test cases, and in the next line, we're given three values as input. X n is first is n number of participants. Next, we have chef's initial score, and then the number of times chef can perform the sabotage operation. Next, I'll just take the input values of other scores of other participants. Yep. Now, next part. So what am I supposed to do next? Now I have this sabotage operation, right? I can perform this sabotage k times. So what will be my chef's new score? Chef's new score will simply be 100 into the number of times we can perform this sabotage operation. And now I will simply get the count of how many participants that are there whose score is greater than this one. And for that, as I said earlier, we can do a simple iterative we can simply iterate over the participants array, or if you want to optimize that part, we can even go with binary search as well. So let me quickly go with the second approach, binary search approach. So for that, I will first sort the array, and I will write this function which is supposed to give me the number of count of participants whose score is higher than chef's current score. So quickly initialize my low and high variable to n minus 1. Now I will have my answer index, which I will first initialize to n, and while low is greater than or equals to high, right? So here we are doing a sealed binary search kind of approach. So if my a of mid is greater than my chef score, then I will store that index and then search on the left side. Else I will search on right side here. And simply at the end, to get the count of number of participants, I have to perform now n minus idx operation, right? So this will simply give me number of participants whose score is greater than chef score. If there are no participants whose score is less than chef score, then idx will remain n itself, and at last will return n minus n, which is 0, right? That is the answer we want as well. So let's quickly call this function. Yep. But this is not the entire code. So what else do you have to do? We can make these participants score to 0 as well, right? How many total participants score we can make to 0? We can make at most total k participants score to 0. But here we have to validate one thing, that is k should not be less than my current count, right? If there are only two participants whose score is higher than chef's score, then there's no point in sabotaging three participants or four participants, right? We'll only sabotage those two participants. And after that, my chef's rank will simply be count plus 1. Let's quickly try to run this and see. Yep, it's passing the sample cases. Let's quickly submit this as well. Yep, it's. Let's see the third and last problem of the video. GCND is the name of our problem. The greatest common non-divisor of two positive integers x and y, satisfying x is greater than or equals to 5 and y is greater than or equals to 5, denoted GCND. Is defined as the largest positive integer z satisfying the following conditions: z should be less than or equals to x, or z should be less than or equals to y, and x is not a x is not a multiple of z and y. X is not a multiple of z and y is not a multiple of z. It can be proved that as long as x and y both are greater than 5, GCND of x and y always exists. You are given an array A of length n, in which every element is greater than or equals to 5 and less than or equal to 10 power 7. What we have to do is compute the maximum GCND of two elements of the array. That is, across all pair of indices I comma j, compute the maximum possible GCND. So let me quickly explain the problem statement. In the input, we are just given n elements of the array, right? And we are just given n elements of the array, and what we have to do is compute the value of maximum GCND. What is GCND? Greatest common non-divisor, right? So how do we determine what is the greatest common non-divisor of any two numbers? So let us suppose say x and y are, we are trying to compute the GCND of x and y. A number z can be termed as GCND of x and y if that, let us suppose a number z is less than equals to z or lesser than equals to y. So it doesn't have to be lesser than both of them, but just any of them, right? And z of course has not to be a multiple of x and y as well. And among all such pairs, we have to compute which pair, we have to compute the value of maximum possible GCND, right? Uh, 8 and 5. So since we have just two numbers, we don't have to check for every other pair. We'll just check with this two pair, right? So 8 and 5. So our GCD first of all has to be lesser than at least one of the numbers. So maximum possible GCD that we could achieve in this case could be, we have to first start checking with 7, right? So 8 minus 1, 7. Now what I'll do, I'll check, does 7 divides 8? No. Does 7 divides 5? No. So this is what will be my answer. This is what will be my answer. 7 will be the GCD in this case. GCND. Yep. Let's take the next example. Here we have 6, 6, 6. Since all the values are 6, my GCD here will simply be 6 minus 1, which is 5. Right? 5 does not divide any of these numbers, so 5 is what my answer will be. Let's take the third example, which is 8, 9, 8, 8. So in this case, which two numbers will give me the maximum GCD? Let us take 8 here and let us take 9. What would be the GCND in this case would be 7, right? 7 is lesser than both of them, although it doesn't have to be, my GCD just has to be lesser than any one of them, but if it is lesser than both of them as well, it's fine for me. It is lesser than both of them and it does not divide any of these numbers. So this is what my GCND would be. What would be the GCND of 8 and 8? GCND of 8 and 8 as well will be 7 itself. So if we, even if we choose pair 8 9 or 8 8, both will give us maximum GCND value, which in this case is 7 itself. I hope the problem statement is a bit clearer now. Now let's see how we can solve this problem. So the brute force solution that comes to mind is simply we want to find the maximum GCND value, right? But we don't know which pair will give us maximum GCND value. So my brute force solution could be to just check the GCND value of each and every pair, right? Check GCND value of each and every pair. But how will we do that? How will we check what could be the GCND value of any pair? So let us suppose say we have x here, and we have y here, right? So how can we check what would be the GCND value of this pair? What's my first condition? The GCND value of these two numbers should be lesser than or equals to at least one of them, right? So it cannot be that I cannot select a GCD value which will be greater than both of them, right? It has to be lesser than one of them. So first what I will do is I will find the max of x comma y, right, and minus 1. This is where I will start checking. I will check first with this value, right, if this is a valid GCND pair or not. That means simply check if this value divides both of them. If it divides both of them, then this is not my GCND. I will simply subtract the value st minus minus and then check the next pair. So I will keep on doing this until I find an st which does not divide both of them. That would simply be my GCND value, right? So this would be my logic to find the GCND of any pair. But doing this logic for every pair, will it be will it pass all the cases? If you look at the constraints here, my length of the array is going up until 10 power 5. So checking for every possible pair is not an optimized solution here. It will not pass all the cases. So we have to optimize that part a little. Now tell me one thing, what could theoretically what could be the largest GCND value we could get from any array? Ideally, the largest possible value we could get from any array would be max value of that array minus 1, right? This could ideally be the max. This will only be the maximum possible value we can get. We cannot get any value that will be greater than this. So if we want to find the maximum GCND value, then this value, whatever is the maximum value present in this array, here AR is an array and max of AR is denoting the maximum value present in this array. So the point that I was making was the maximum GCND value, whichever pair will give me that pair has to have this maximum value, right? So I'm making this observation here. And next part would be simply check by including this maximum value of the array with every other element of the array. Compute what would be the GCND, and amongst all of them just choose the maximum. Among all of them just choose the maximum. I hope you guys are following my logic. So I'll repeat it once again. Since finding the GCND value for every possible pair is time consuming for us, what observation I am making here is the maximum possible GCND value from any array that I would get would be the maximum value of the array minus 1. So if I want to get the maximum GCD value, this maximum value of the array has to be one number from that pair that will give us that answer. So for that reason, what I'll simply do is I'll have this maximum value of the array as one number of the pair, and for other number of the pair, I'll just simply check with each and every element of the array. And amongst all of those values, I will at last simply choose the maximum one. Let's move to the code part next. If that could only happen, GCD is remaining 0, right? So this third case itself, my maximum value has my 6 is the maximum value, and all the elements present in the array are 6 itself, right? So in that case, this statement will never get executed and my GCD will remain 0. So if GCD is remaining 0, then that means there are 2 occurrences of my maximum element. In that case, my answer would be simply GCD of this pair, max comma max. And at last, simply print whatever is the value of present in my GCD. Let's quickly try to run this and see. Okay, we're getting wrong answer for the third case. So let's look at the code again. Here we are not updating my GCD value, right? So after getting the GCD value, I have to update my GCD value with the maximum value of achieved till now. Let's quickly try to run this again. It's now passing the sample cases. Let's submit this and see. Yep, it's passing all the rest of the cases as well. That was it for this video. If you have enjoyed the content, please make sure to like, share and subscribe for more such videos. See you in the next one. Bye bye.